some programming fundamentals as soon as the page refreshes for me. All right, so code is a written process. So we're always describing, careful, we're always describing some process when we write code. We're writing, usually we're writing a general way to solve a problem, or a way to solve a general problem when we write code. And that's all that we do, really. As programmers, we solve problems. And we figure out first, though, how we're going to solve it. We think about it. We maybe write some things out on paper. We might make some flow charts. We do some research if we have to. But we think through the problem first. We think about how we would solve that problem in a systematic way. And then, before we ever start to write any code. So we have an idea of how we're going to solve the problem, and then we start to write code that is a representation of that solution. Do you have a question, Christy?
Where are the slides?
The slides?
Yeah, I'm working that out now.
Okay. All right, there you go. Matt will work it out. Thank you, Matt.
No worries.
Okay, so oh, GitHub. Okay, just did you did you access the did you click on the, did you get an email?
No.
Okay, you should get an email, and the email address associated with your GitHub account, and then you'll have to click on something. So when we write code, so we have a solution to a problem that we think out. We call that solution. Well, usually that solution consists of some algorithms, and algorithms are just collections of lines of code, or it doesn't have to be code. It could be an algorithm that's written out in sort of plain writing. But generally when we talk about algorithms, we mean written out in code, a collection of lines of code that perform some particular task to solve some particular problem or part of a problem. And then we combine those algorithms in a solution, and that solution will solve some larger problem. So that's all that we do when we write code. It really is. That's all that we do. And in order to do that, we have to break the problem and the solution down into the smallest pieces. So code is very specific. It has to be written in a very particular way, and we can't take anything for granted. We can't make any assumptions. So we'll see what this is like when we try to describe how you do something, and then how you would actually tell a computer to do that thing, with the list of commands that computer understands, or that language interpreter understands, or that language compiler understands. So in order to write it in those terms, we really do have to think carefully about what we want to get done and how to do it. So before we even get to writing code, though, we have to really spend some time on analysis. We have to make sure we understand the problem that we're trying to solve. Because if you don't have a good understanding of the problem you're trying to solve, you're probably not going to write a solution to that problem. You might write a solution to another problem, but in order to write a solution to the problem you want to solve, you have to understand it. In order to understand the problem, you have to understand the people that are involved with the problem. Because again, you may think you have an understanding of the problem, but if you don't have an understanding of the people who are interested in the solution, you probably won't solve exactly the problem that you set out to solve. So there's a lot outside of just straight logic and coding that's involved with programming. You have to spend some time really thinking about what you're trying to do and who you're doing it for and what it is they actually want, and make sure that you're clear about all of it before you even start. A lot of times we'll start coding without being clear about all of it. It's something that I think most developers are guilty of doing. We get really excited about just jumping in. Maybe we feel some pressure, some time constraints, we have to get it done, and we just start writing some code without understanding the problem or the people very well. Then likely what will happen is we'll have to rewrite it. And when you have to rewrite something, it's generally much harder than just writing it right the first time. So I really will encourage you over and over again in this course, when you do assessments, when you do your work, to take that time up front to think about what you're doing and why you're doing it and who you're doing it for and what the expectations are. Make sure you're clear. Once you have a really clear understanding of the problem you're solving and the people who are interested in the solution who you're solving it for, then it's important to think through the way you're going to create the solution. And when you're thinking through the way you're going to create the solution, depending on the size of the project and sort of your skill level and what infrastructure, the complexity of the environment that you're working with, there might be tons of things you need to think about regarding design. So for example, you might want to think about the way that this solution is going to perform when it runs. You might have to think about how many people are going to use this solution at the same time. What are the considerations that I need to take into account when I'm creating a solution that 100,000 people might want to access at the same time? How much data am I going to store? How am I going to store that data? How do I want to access that data? So is it going to, I don't want it to take 5 minutes to access the data that I want to display to the user. So you have to think about, how am I structuring that data so that I can access it efficiently and quickly from my program. You want to think about the user interface when you think about the design. How is a user going to use this solution? What is the flow going to be for the user, and does that flow make sense? So when you're the writer of the solution, you take a lot for granted. You know where everything is because you wrote it, you created it. You know that you just have to click here, here, and here to get to that. But is it going to make sense for a user who knows nothing about the way you wrote the solution to take those same steps? How usable is it? How user-friendly is it? To do a task, for example, a user using your solution, if they're going to do this task every time they use it, if they have to click 5 places to do that task, then that's not very user-friendly. So you have to think all those things out, because if you don't, then it's really easy to kind of forget. You code something and then it gets too hard to code it the way that's user-friendly, like, I'll just stick it here. It starts to get a bit hacky, and then it gets to be really hard to maintain that code or for other people to contribute to that code. So spending some time up front in design is super important, and if you don't take that time up front, then you'll probably be upset with yourself later. If not you, the person who has to work on this thing after you're done with it, they'll be upset with you later and cursing you, even though you won't be there to hear it. So design's really important. Now, once you get through all of that, and honestly that could take as long or longer than actually writing the code, and sometimes it should, depending on what you're building, then you actually get around to writing some code. So you write your solution. You may write pieces of it out in pseudocode, generally in something like a low-level design. So you have a high-level design that says, okay, this is how the solution's going to work, and this is how I'm going to store my data, and what the data structures are going to look like, and this is the general flow of the user interface, and you have some wireframes maybe, and we'll talk more about what those are later and how to make them. And this is how a user is going to use the application, and here are the user stories that describe how the application's used. And then you write a low-level design, typically, at least for maybe the tricky parts of the solution, where you just write out in words, this is how I'm going to code this part of the solution. And then you can take that low-level design and your high-level design and feel pretty confident that what you actually write is going to work the way you want it to work and not be too painful to write or maintain or test. Now, testing is really important. Some coders have this sort of lofty opinion of themselves, like testing is not my job. Hire a tester to test. Testing is not, my code is perfect, it's beautiful, works for me every time. Every time I run it, it works. But testing is really important, and not just manually testing to make sure that your stuff works, but making sure that your code is testable in an automated way. Because once you have a product that grows large, or a product that has a long life, and you have to make changes to that product over time, because you never just write something and then you're done with it. If if you write something and you release it out into the world, you are obligated, if you want to keep your reputation as a developer, as a company, to maintain that thing that you release to customers. Because customers will use it, and I promise you customers will use it in ways you never imagined or intended for them to use it. And then they'll complain that it doesn't work the way they expect it to. And they'll raise tickets, and they'll call, and they might even write the CEO and complain if you don't do something about it. And then you start to get really nervous about making any changes to this code, because you don't want to add functionality, because then who knows how they're going to use it, and you don't want to change something that's working or been a source of bugs for the customer, because you might break it again. And so a way that you can write code and have some confidence about it and feel good about what you're writing and putting out there and feel happy doing your job instead of anxious and nervous about it is to write code that is fundamentally testable, and for which you can write unit tests and automated testing, and that you write those tests as a developer and make that a priority for yourself when you're writing code, that you write tests for your code. Some teams that you work on will demand that. I would say a good development team, a team that I would want to work for, would demand that. That would be a part of the process of writing code, is that developers write automated tests for their code.
The test plans can sometimes take longer to write than the actual code itself, which is frustrating as a developer, because you're trying to get something done, you finished it, but you need to spend twice as long actually writing all the unit tests and the testing so that it all...
That's right. And writing unit tests, guess what that is? That's writing code.
Yeah.
So you have to
write code to check your code.
You have to write code to check your code. That's what automated tests are. Is code that you write to test your code that you're going to write. So it can start to feel sometimes, and you can understand. I can empathize totally. I've been a developer for a long time. I totally understand the resistance to doing that. Like, I got enough code to write to get this feature done. I don't want to write twice as much code to be able to test my feature. But the thing is if you don't do that, you release it out to the customer. When you work on a product that gets heavily used, you might release it out to hundreds of thousands of users or millions of users potentially, and they are going to abuse that thing, I promise. And then it's going to come back with problems. And if you don't have tests that test at a low level and at an end-to-end level the functioning of your code, then it becomes very difficult to isolate, why is this problem occurring for the customer? Why is it not working the way that they expect it to? And if they expect a feature to work differently and you have to enhance your product to meet the customer's expectation, it can become really hard to make those enhancements with any confidence if you don't have a lot of good testing in place. So testing, I think, needs to be of paramount importance for developers. Another thing that isn't written in this slide, but also needs to be really important, and it comes into the design, build, and test phase, is accessibility. So I've only recently become pretty passionate about accessibility, because for a long time I was a developer who was a bit naive and probably a bit closed-minded and just a bit maybe entitled, even the way that a lot of people are in the world, about the accessibility of things in general in the world. So I can see and I can hear and I can move around pretty freely, and so I don't think about people who can't, and how using a product can be completely impossible for a large portion of the population because of the accessibility of that product. And really, when you think about it, what's available on the internet and through software, through apps, through devices, and then as we move forward, through Internet of Things, just embedded everywhere, we want those things to be available and accessible to everyone. You don't want to cut out large portions of the population from being able to use this thing you're creating. I mean, for me, what we do as developers is we create solutions that make the world more easily available and accessible for everyone. So everyone has access to these things that make life better and easier and more fun. You don't want to cut people out of that. And if you don't think about accessibility from the start and you try to put it in afterwards, it's super painful. I know this from experience because generally, almost every product I worked on, accessibility was an afterthought. And I worked for large corporations. You'd think that they'd have it in the front of their mind, but it was not made a priority on the teams that I worked on. So as a developer, not aware of it myself, I just did, what I was expected to do. We're always under time constraints. We never have enough resources on the team, so we're not going to volunteer to do things that we're not asked to do. But what happens is you suddenly want, to get a government contract. You want some government entity to use this thing that you've made. They're going to demand that it meets the accessibility requirements. They will not give you any money for that product if it does. You won't get the contract if accessibility is not there. And trying to retrofit accessibility into an existing product, it is impossible. It is. It's so expensive. It's so costly with time and money. Yeah, exactly. So it's super important to consider accessibility from the start. One more area, and this one is my least favorite. It's the one that I care least about, but I know it's important, is security. So I just, I have this innate resistance to security, and I think it's just because of my kind of optimistic way of looking at the world. I like to think that we all will be kind and take care of each other and not take advantage of each other, but I understand that's not the world we live in. So security becomes really important. It becomes more and more important as we move forward and more things are digitized and more information is out there and available and accessible to anyone who wants to, who has the ability and the skill to take advantage of that and abuse it. So security is another thing that becomes really important that you need to think of as a developer. So all of these things that you have to think about, they go into the code that you write, but you have to think about them before you write any code at all. And then you have to think about them while you're writing code, and when you maintain that code, and when you make changes to the code. You have to think about those things all along the way, and it's really important. So once you, generally you don't wait until you're done building something. When you have something that's deployable, you deploy it in a test environment and a development environment. So you generally have a development environment, that's where your developers are working, a test environment which is taking maybe not the very latest, the like live version of that code, but pretty close. You might have multiple test environments. On a lot of large projects, you'll have multiple test environments that are testing for different maybe hardware environments and different versions of the database being used and different versions of the other pieces of middleware. So the last job I had at SAP, we had, probably 6 or 7 different QA test environments because we had ones for 3 different level versions of the database because the database we were using was really new, really green, SAP HANA. It's an in-memory database. It was very young and volatile. So we would test on, the stable version of the database and the one that was currently released in production and the one that was about to be released. And so we had an environment for each of those and, environments for sort of different configurations that we might have in data centers. But ultimately, when you've got something releasable, then you deploy it to your end users. You release it to the world. And once you've done that, then it's your responsibility, like I mentioned, to maintain it, to keep it up to date, to fix problems found by customers, to continue to enhance it to meet your customers' needs until you formally end-of-life it. So once you put something out there in the world, you have an obligation that you may or may not uphold. Again, it's about your reputation as a developer or as a company. You have an obligation to support that thing until you formally announce to your users that you're going to stop supporting it. And you give them some period of time that you generally have agreed to up front when you release this product, or when those users signed a contract that says, okay, I'm going to continue to support this until I tell you I'm going to stop. I'm going to give you 6 months or a year after I say I'm going to stop supporting this for you to move to the next thing, that solves your problem.
And I think in GitHub you'll see it a lot. There's people will just stop kind of, you'll see last update, 4 years ago. You're like, gosh, damn, darn it.
Yes.
You're gonna find one that's a bit newer.
That's right.
So,
That's right, because if they haven't touched it in 4 years, if you find a problem, they're not going to touch it.
no.
Yeah, there's going to be
They're not
nobody
gonna
on the
answer
other.
your email.
Yeah, that's right. That's right. There'll be nobody on the other end. So these are all things related to programming, things that you may or may not have thought about before. So it's not just about writing code and putting it up on GitHub. There are a lot of things to consider if you're going to be a developer of good reputation, or if you want to do your own thing and release software under your own company. If you want to be successful doing that, you really need to consider all of these things. So, so this basically is a short version of some of the things that I just said. So we can consider, has anybody seen the hierarchy of needs before? So this is just for human beings, the hierarchy of needs. So we have, at the bottom we have the basic needs of food, water, warmth and rest, and security and safety. And we have psychological needs. And then at the very top we have self-fulfillment needs. So we can think of a similar pyramid in today's world. And at the bottom below physiological needs, we have the need for Wi-Fi and battery life. Those things become very important for us, don't they? But we can also think about what makes up quality software, the hierarchy of needs for code. So this is all debatable, okay? And you can kind of move things around a bit, but this is a generally accepted. Now I think I added number 1. I can't remember if it was me or somebody else who added number 1 below functionality, usability. Now it has to function, obviously, but I argue that if it functions and it's not usable, who cares? Because nobody's going to use it. So it has to be usable. It must be usable. You can create something that works perfectly, like it does exactly what it's supposed to do without ever doing the wrong thing, but if nobody knows how to use it or wants to use it, then you just wasted your time creating that thing, It's just a little bit of an ego stroke for yourself and nothing else. So usability is really important. It should be something you're thinking about. Functionality, of course, is important. If it doesn't do what you say it's going to do and it doesn't do it reliably, then it's not of much use, right? Nobody's going to want to use it. They'll get frustrated with it and not use it. The reliability and robustness of the thing that you create. So if it functions most of the time, but there are certain times that it never functions correctly, that it's unreliable, then people aren't going to trust it and not going to use it. If it functions all the time except under certain conditions of load or stress and it's not robust, then it's going to be useful maybe to a smaller population of users. There's going to be a whole bunch that you cut off because your application's not robust. Maintainability is also really important because, like I said, when you create this thing and release it to the world, you're obligated to maintain it afterwards. And if it's impossible to maintain because it's spaghetti code, because it's not well written, it's not testable, it's not tested, it's not well organized, somebody can't come in and look at it and have any, they have to spend 2 years sorting through it to figure out what the hell it's doing, then it's not going to be good code. People are going to stop maintaining it because it's too hard to maintain or costs too much to maintain, and you'll have to abandon it and start over again. So maintainability is really important. That's the ability to make updates to and fix your code. It's really important. And extensibility and portability. Portability probably has become more important. Well, not probably. It has become more important that the applications that you write can run in different platforms. So because we have mobile devices and we've got iOS, we have Android, and now with Internet of Things, that's going to make it even more so. So the pieces of code that you write, if it's portable, that means that with the effort that you've already spent writing this code, you can reach a lot more users, right? If it's not portable and you've got to write, rewrite the whole thing to run on iOS, and rewrite the whole thing to run on Android, and rewrite the whole thing to run in other types of environments, then that makes it less useful, less beneficial.
You can do that in different languages.
Yes, in different languages, yes. So there are ways that you can write your code, though, and organize your code so that you minimize the pieces that have to be reworked. And there are frameworks available that aid with that. So that port it out to both. So React Native has become super popular lately.
Yeah, we use that.
Yeah, because React Native not only allows you to write something once that'll run on multiple mobile platforms, but it also is very much like React. So it's not like you have to have somebody with a completely different skill set to be able to write your application for mobile devices. Extensibility is the ability for other people to extend, third parties to extend your product. And that just means that your product becomes available to more people. So it's a very popular thing for some company or organization to write an application, and then for third-party providers to provide extensions to those applications. So we see that in VS Code, don't we? So VS Code is an application that's available, and there are heaps of people who are providing open source extensions to VS Code, and that makes it more likely that people use VS Code because of all the cool extensions that are available, right? So extensibility is something that extends the reach of your code, extends the number of users that will want to use it, that will be able to use it, and you have to build extensibility into your application. So if it's too hard or impossible for a third party to write extensions, then they won't, right? But if you write your application in a way that makes it easy and possible for third parties to write extensions, then they do. And then your product becomes more popular. So there's, of course, the monetary side of that. You sell it to more people, potentially, right? And that means more money for you. But what I'm more interested in is that means this thing that you built with the intention of making things easier and good for people is now available to more people and does those good things for more people, right? So that's good. And then at the very top, and keep it at the very top, is elegance and efficiency. Now, efficiency, I would say, is more important than elegance. Elegance is nice. Elegance does add sometimes to maintainability. Depends on what your idea of what's elegant is. If your idea of what's elegant is writing everything in one line, okay, you can argue that's elegant. It's probably not maintainable, right? So elegance is nice. It can be frustrating when you're maintaining code and somebody's written something in a way you're like, why in the hell did they write it that way? That is so inelegant. But it's not like, it's definitely at the top of the pyramid for me. So it's nice to have as a goal to write elegant code, but it shouldn't be your first priority. You should focus on the other things first. And it's nice to have code that's efficient. And sometimes it's really important to have code that's efficient if we're talking about things like performance. But if we're talking about, the efficiency of how long it takes you to write it or how long it takes somebody to maintain it, that's, I'd say, more important than elegance. And they're kind of related to each other in some cases. Does that make sense to everybody, that hierarchy of needs?
Your code does have to be readable.
Yes.
Because other programmers have to be able to understand it later on down the track. And when I say other programmers, that includes yourself, which we must time.
That's right.
And
Trust me on this.
comments as well is
Yes.
really important.
Oh,
It
yes.
is.
Yeah.
And to have them in the right format kind of is really important because there's specific standards of comments that they have out there that you can sort of need to comply with sometimes.
Yes.
So,
It would be good for, maybe you want to talk about that sometime, because
Okay.
we don't really
Yeah.
talk about that very much.
Yeah.
That would be good. It is important. So for example, if you're writing in Java, you'd want to write Java formatted comments so that it's, so that you can read them easily. You know exactly what to look for and how to look for it, and things are the way.
And there's some packages out there, if you write them in the right format, you can run it through a documentation program, and it'll actually create all of the documentation automatically for all of the code you've just written. So you don't have to go and create
separate documentation. Yeah.
So it does come in handy. And as well, when other developers are looking at it, it's just so much easier to see what they were trying to do.
Especially when you're doing something all the time, but the places where it gets people in trouble when they don't is when you've made a choice that isn't the obvious choice in an implementation in your code, and you made that choice for some good reason. So maybe you tried it in the way that most people would think, oh, this is how I would do it, and there was a problem with doing it that way that you found in testing. There's some reason, some incompatibility with something else, and you don't document that in your code comments, then somebody, it could be you, 3 months later, looks back at it like, why did you do it? Why is it this way?
It could be the guy next to you.
It could be the guy next to you.
I'm
going to change that and put it the way that makes sense, and then they find the same problem you found when you did it originally. So code comments are really important, absolutely, and readable code is really important. So things like variable names and function names and file names and directory names should make sense and be consistent. Yes, and not just like pulled out of the air or single letters or something like that. So there's a fine line between laziness and complete irresponsibility when it comes to the way that you're naming things in your code. So I've used some really long variable and function names before when it made sense to do so, to make it really clear about what this thing is doing, or file names even, And sometimes there are conventions for the particular language related to those namings, and sometimes there are conventions related to the organization that you're working in, and so you should be familiar with those, and that's important. That's important for maintainability. Okay, in 10 minutes we have a mentor coming in. So we'll continue until he gets here by sharp. All right, so this is the last slide for right now. Anyways, that's good timing. And then we'll do a bit of a challenge together. So what's procedural programming? Procedural programming is programming where we have a series of steps that are executed in order. And it could also contain calls to functions. So we've got, do this, then do this, and then we might have call this function. And when we say call this function, it's going to hop up to where that function is defined and execute the steps in that function, and then return back to where it was. Okay, now do this. Now do this. Call this function. It'll hop up to where that function is defined and execute that function, and then come back to where it was. Most languages can be written in a procedural way. So the majority of programming that we do will be procedural programming. Languages designed to be used procedurally. Some languages are designed to be used procedurally. Other languages are not necessarily designed that way, but can be and are often used procedurally. So those are just some languages designed to be written procedurally. Another programming paradigm is object-oriented programming. I'm sure everybody's heard of that. So object-oriented programming is when we define objects based on templates, which are generally referred to as classes, but not necessarily could be called prototypes. And these are templates that define what this thing looks like. And then those objects will have attributes and actions that can be performed on them. And the objects in a program interact with each other in order to solve problems. So that's a really short, high-level description of what object-oriented programming is. But it is, you can maybe tell from that description how it's different from procedural programming. Okay, so that's the slides that we're going to cover right now. And now what we're going to do is we're going to have a look at the Canvas challenge, and then I want you to I think what I want you to do The challenge says to write an algorithm for making a peanut butter and jelly sandwich. I know peanut butter and jelly sandwiches aren't popular in Australia, are they? I love peanut butter and jelly sandwich. Yeah?
This is from the CS50 lecture.
It could be. Yeah, it's really popular. I've used it in all sorts of, I've seen it and used it in all sorts of, I think it's just sort of like a common kind of challenge to do. So using a vocabulary of just 50 words, so you can choose the words that you use, but you only can use 50 words, to write an algorithm for making a peanut butter and jelly sandwich. Assume that all the ingredients are in the refrigerator and that the necessary tools are in a drawer under the kitchen counter. The instructions must be very simple and exact because the person making the sandwich has no knowledge of food preparation and takes every word literally. Okay? So I want you to each do this yourselves, and then I want you to partner up, have the other person read the instructions and see if you can find flaws with the way that it's written. Does that make sense?